Hello friends, today I'm going to discuss about expansion of cos x and sin of x. Now let's prove. We know that we know that cos of n theta is equal to cos power n theta minus n minus 1 by 2 factorial cos to the power n minus 2 theta sin square theta plus n minus 1 n minus 2 n minus 3 by 4 factorial cos to the power n minus 4 theta sin 4 theta minus and so on of the infinity, and sin n theta is equal to n cos to the power n minus 1 theta sin theta minus n minus 1 n minus 2 by 3 factorial cos to the power n minus 3 theta sin cube theta plus so on up to infinity. Now putting n theta is equal to x, then n is equal to x upon theta. Now from cos n theta we will get cos in place of n theta we will put x, so cos of x is equal to cos to the power n theta minus in place of this n we will put x by theta, so it is x upon theta minus 1 by 2 factorial cos to the power n minus 2 theta sin square theta plus here, so in place of n we will put x by theta, so it will be x upon theta minus 1 x upon theta minus 2 x upon theta minus 3 by 4 factorial into cos to the power n minus 4 theta sin 4 theta plus and so on. Now let's simplify. Cos of x is equal to cos to the power n theta minus x minus theta by 2 factorial cos to the power n minus 2 theta sin theta by this theta and theta square, so it is theta whole square plus here, so x minus theta x minus 2 theta x minus 3 theta upon 4 factorial cos to the power n minus 4 theta sin theta by here this theta, so it is 4 times, so it is theta over power 4 minus and so on. Now by keeping x as constant and makes an infinitely large and positive integer, then theta is accordingly diminished. To make 0 diminish infinitely, then is we know that limit theta tends to 0, cos of theta is 1, and limit theta tends to 0, sin theta by theta is equal to 1. Therefore, this one can cos of x is equal to, so cos to the power n theta is, so if we take limit, so it is just 1 minus, and this one theta is just 0, so it is 0, so we will get x squared by 2 factor into this is just 1 into this also just 1 square, plus here also x to the power 4 by 4 factorial into 1 into 1 to the power 4 minus and so on. Therefore, cos of x is just 1 minus x squared by 2 factorial plus x4 by 4 factorial minus next term will be x6 by 6 factorial plus and so on up to infinity. This is expansion of cos of x. Now for sin of x, from this same thing, putting n theta is equal to x, then this, so similarly instead of n theta we'll put x, so it will be sin of x equal to, and here n is x upon theta, so this become x by theta, and cos to the power n minus 1 theta sin theta minus x upon theta, x by theta minus 1, x by theta minus 2 by 3 factorial cos to the power n minus 3 theta sin keep theta plus and so on up to infinity. Now if we simplify this, sin of x is equal to x cos to the power n minus 1 theta sin theta by this theta is come here minus here, so you will get x minus theta, x minus 2 theta by 3 factorial cos n minus 3 theta sin theta by theta this 1 2 3, so theta k 4 k plus and so on up to infinity. Now similarly from here, by keeping x as constant and make an infinitely large and positive integer, then theta is accordingly diminished infinitely, then is limit theta tends to 0, cos of theta is equal to 1, and limit theta tends to 0, sin theta by theta is equal to 1. So similarly we will get sin of x is equal to x into cos will be 1, sin is 1 minus here theta is 0, so it will be x cubed by 3 factorial into 1 into 1 cube plus and so on. Therefore sin of x is x minus x cube by 3 factorial. Next time will be x5 by 5 factorial. Next time will be x7 by 7 factorial plus and so on up to infinity. This is expansion of sine of x.